Okay, so here we go. Welcome to the Gardener review meeting. Today we look at the 1.137 release. And the agenda looks as follows. I will start with two topics. First one is about the GEPs that now move to the new Gardener enhancements repository. And the second one is about a small new feature in the secrets manager. Then we have Radoslav with the VictoriaLogsBackend feature gate. Johannes with the node-specific configuration files in Gardener Node Agent, and finally Luca with the new Go submodule for the Gardener APIs. All right, then let's get started with the first topic, which is about this one. So there was actually an issue already opened almost a year ago that the enhancement proposals would probably be better moved to a central repository, similar to how it's done also in the Kubernetes community, where there is this Kubernetes enhancements repository, because it's easier for tracking and for handling the proposals. So we finally had some time to implement this. So basically all the gaps that previously were in Gardener have been moved out of the repository. And there's now, similar to how Kubernetes is doing it, this Gardener enhancements repo. There's this GEPs folder, and each proposal has its own directory, starting by the GEP number. And yeah, the README is then basically the proposal itself. And there's also a small YAML file with some metadata about the proposal that could be used by tools if needed. There was also this Slack announcement, if you haven't seen it, in the Gardener Workspace general channel. So there's also a link to how the process now works, because it's slightly different. So if you want to propose a topic, then basically this guides you through what needs to happen. First is that you should probably circulate your idea a bit in the community to check how much interest is there. And yeah, when you have done this, you create an issue here. The issue number is basically the GEP number. Then you create the proposal file and open the pull request. And the idea is that all the GEPs that have been proposed here will eventually be discussed in the Gardener technical steering committee at some point in time. So this is also what the Slack post explains. So the first, these GEPs will be reviewed asynchronously, just like a normal PR review. So authors and reviewers can have a bit of ping pong feedback and bring the document into a good shape. And yeah, when everybody is more or less happy with the state, then a meeting is scheduled and the most relevant open topics are discussed in person then in this meeting. So this one change, and another one that we did this week is that we have discontinued the product steering committee. So there's now only the technical steering committee. The reasons are basically listed here. So in most cases, the division that was actually the goal of this meeting was already clear beforehand, because the proposers had usually already discussed this with others and also with the sponsors. So when somebody wanted to work on some topic, it was more or less already clear that this will happen. And in the product steering, we were not really focusing much on the technical aspects. So it was not really clear, and always a bit of mixing what the actual purpose is. So we figured out that it makes sense to only continue with this technical steering for now and handle all the proposals there. The community webpage here is also adapted if you want to go over it once again. So it only talks about the technical steering, why we have that, and also the process how to propose a topic, and also what happens after a pull request has been opened in the Gardener enhancements repository. On the left side, you can see all the gaps and all the meetings that we had. So there's a link to the issue itself, to the document, and when we had the meeting, also a recording, of course, and decisions that we have done there. Yeah, I think that should be the high-level update. As said, if you want to look into the details, then feel free to check out the links in the Slack post. Any questions so far? If not, then I continue with the next topic, which is about the secrets manager. Actually a small feature, but can be useful in some cases. So what is this about? I added an option to load missing CA secrets directly from the cluster. So let's look into some code to understand why this is relevant. Here I've prepared a small program. We set up a client and a secrets manager. And then the usual flow is that you first have to generate your CA certificate. And when you later want to sign server or client certificates, you then need to have the CA generated first. So you cannot just directly create a client certificate or a server certificate. You always have to first generate the CA in the same instance of the secrets manager, basically. So when we run this, currently there are no secrets. We now should get the CA, the corresponding bundle secret, and the server secret. Exactly what we have described here. And what is not working is if I don't generate the CA and try to execute the code again, then we will get an error that the CA is not found in the internal store of the secrets manager. Now with the PR that I mentioned, I added a new option, which you can specify here, where you also specify which CA should be used to sign the server certificate. So you can do something like load missing CA from cluster. And if you do that, the CA will be tried to be fetched from the cluster instead of only looking into the internal store. So running this code again should now work. Nothing changed because it already existed. But of course, we can also generate a new certificate because the CA is already here. So this can be useful. In our concrete case, we needed it for the GEP 28 for the self-hosted shoots, where we join control plane nodes with the Garden ADM join command. And we have to generate machine-specific etcd certificates with the node IPs in it. And the CAs are already there, and we don't want to generate them beforehand. So this made it a bit easier for us in the implementation. Of course, if you try to use a CA that does not exist in the cluster, then it, of course, doesn't work. Yeah, that's mainly the change. In the same PR, I also adapted this new function a bit. So it now takes the last argument these option or config functions. So there is something like with namespaces now. And we can also check here. There are some other config functions that you can specify, which makes it a bit easier to set up the secrets manager itself. Okay, that's all I wanted to show. Questions or feedback before we move on? If not, then next would be Radoslav with the VictoriaLogsBackend feature gate.
Yes, thank you, Rafael. Hopefully everyone can see my screen and can hear me well. I should be pretty quick. The topic I actually want to talk about is part of the implementation for GEP 35. GEP 35 basically consists of replacing the whole migration steps that are needed for replacing Vali with VictoriaLogs. It is kind of an evolution of GEP 34, and it basically encompasses the whole observability 2.0 project. The new feature today that I want to show is one part of the implementation of GEP35. It's actually this pull request here. The whole pull request, what it does is it provides a feature gate called VictoriaLogsBackend that when enabled, it just deploys a VictoriaLogs instance everywhere where Vali would usually be. Vali still remains, so they are deployed simultaneously. And you can imagine that everywhere where you see Vali, you should now see an instance of VictoriaLogs. The next step after this would be actually to create a feature gate that when enabled would remove Vali and leave only VictoriaLogs. But for now, we're up to this point where we're only deploying VictoriaLogs. For more information on the implementation, there's also an issue that basically outlines the three individual steps: the deployment of Victoria operator, then the deployment of the VictoriaLogs using Victoria operator, which is the thing I'll be talking about today, and the final step of removal of Vali. Architecturally, it's pretty simple to show. This right here is the current setup that we have for logs that are collected from the data plane. So on each shoot cluster, there is an instance of OpenTelemetry collector, the replacement of Valitail. And that instance of OpenTelemetry collector sends the logs to a collector in the shoot control plane. And then from there on, the shoot collector sends it off to Vali. Well, the change is pretty simple. From now on, the OpenTelemetry collector will send to VictoriaLogs. Now, I've left it off here, but it kind of seems like Vali has been completely replaced by VictoriaLogs. Again, I want to say that this hasn't happened as of yet. We only have developed an additional deployment of VictoriaLogs. So the actual implementation detail is that the collector here has now been configured to send logs to both VictoriaLogs and an instance of Vali that you can't see in this picture here. This is the shoot data plane collection of logs for the seed and garden cases. This is basically the picture. Again, it's very simplified. Different bit instances, they usually they're configured to send to the OpenTelemetry collector, and then the OpenTelemetry collector again sends to Vali. Well, in this case, again, picture is the same. Vali receives logs, but now VictoriaLogs is deployed as well when the feature gets enabled, and the collector sends logs to VictoriaLogs as well. As a demo, it's honestly nothing. There's nothing much to see. I have a local cluster here on my machine. If we get all pods, I've also deployed a shoot in this cluster. If we get all pods and then grep for VO single, this is the name of the pod. We can see that now when this feature gate is enabled, we have an instance of VictoriaLogs in the garden namespace and an instance of VictoriaLogs in the shoot namespace. Again, if we check pods in the shoot namespace, we can see we have Vali, but we also have an instance of VictoriaLogs alongside with it. Maybe one interesting thing to see is that VictoriaLogs also hosts its own dashboard, since Plutono, as you know, we're currently using Plutono as the front end for viewing the different data sources, such as Prometheus and Vali itself. Well, sadly, Plutono does not have an integration with VictoriaLogs. So there will be during the migration period, there will be a point of time where the logs will be visible through the actual VictoriaLogs instance. So if we can port forward the VictoriaLogs service, so that we can view the UI. And maybe this will be interesting for people to experiment. You can take a look at the UI. Ideally, if everything works correctly, the logs that you can see currently in Plutono through Valley, you'll be able to see them as well through the VM UI. This is the name that the Victoria Metrics team has given to the UI. And it's pretty feature rich. I'm not as of yet an expert, but it is, for example, here in the overview, there's some interesting statistics that can be viewed. You can see what kinds of fields are actually the VictoriaLogs instance is actually seeing. So we can see there's origin, there's some open telemetry, specific semantic labels like Kubernetes container name. There are also individual streams. So if someone wants to have some fun, they can just create their local setup. And since it has currently been enabled by default on the local setup, you will see the instance of VictoriaLogs, and you can play around and check out the dashboard if you want. And yeah, that's it for now, but expect more updates in the future as this topic progresses. Are there any questions? This is everything from my point. Okay, thank you.
Thanks, Radoslav. And let's move on. Johannes is next with the node-specific configuration files in the Node agent.
Okay, hello from my side. I hope you can hear me and see my screen. I will be showcasing basically this PR here, which allows you to create node-specific configuration or files with the operating system config. Now you may wonder, why do we actually need that? The operating system config is used to bring something on the nodes, basically, for example, systemd units or configuration files like the keyplate configuration. And in general, we want to have the configuration the same for all nodes in one worker pool. So why would we actually need such a feature to have a node-specific configuration file? Well, the context is the GEP28, so basically self-hosted shoot clusters. This feature is not so much relevant for hosted control planes, because as I said, for hosted control planes, we assume, and we have currently implemented everything that we don't need host-specific configuration, but in the self-hosted shoot cluster case, in particular for the control planes, we will eventually have node-specific configuration, meaning that, for example, for the etcd, for an HA etcd setup, we need individual certificates generated for each node. And therefore, as we don't want to distribute the certificates to all the nodes, we just want to distribute them to the nodes that really need them. We somehow need a way to specify that a certain file should only be rolled out to a particular node. So now, what does it mean in reality in the code? Basically, in the operating system config in the file struct, we just add another field, the hostname field, next to path, permission, and content, so that if you specify a hostname, this file will only be rolled out exactly on this host. If the hostname is not specified, then it's basically the same behavior as before, meaning that the file will be rolled out to all nodes of a worker pool. It changes a little bit the duplicate entry handling. In the past, you could not have duplicate entries for a path. Now you can have duplicate entries if for all of the entries the host name is set. So basically, if you have multiple nodes, you can have a node-specific configuration for the same file path if a host name is specified all the time. So let's look at that in a real-world example, or a little bit real-world. This feature is not used yet because we don't have HA self-hosted shoot clusters yet, but with a little bit of additional massaging from my side, I can show you this in a self-hosted shoot cluster. So I have created, as you can see in the top left, I have created a self-hosted shoot cluster in the local setup. I have massaged the operating system config for the worker pool a little bit. So you can see here on the lower left part, the important content. I have added basically 3 files for the 3 nodes in my cluster. Currently, only the control plane node is part of the cluster, but we will join the worker node soon. And we can basically see that even though I showed just one operating system config, I also did the same for the control plane operating system config. We can basically see that in my control plane node, so machine 0, I have the host specific machine 0 file, or the content of that file there. Now, if I want to also join the other nodes, so I just get me a join command, and now I magically first I check on the other nodes. Yeah, the file is not there on the nodes, obviously, because we have not joined them to the cluster. So Gardener Node Agent is not yet running on those nodes. But if I can copy and paste it here over to both nodes, so joining the nodes, which get done fairly quick. So the nodes will join the cluster. We have machine 1 and machine 2 now joining the cluster as Kubernetes nodes, which we will hopefully also see fairly fast in the cluster. Yeah, so the nodes already joined. They are not yet ready, but this will come soon. Now we see the nodes are also ready. And if I now basically take a look at the corresponding files I rolled out, you see that basically for machine 1 and for machine 2, we have the individual different content. Well, it's just the index here that I changed. But you can imagine I could also now provide different TLS certificates for the individual nodes this way. And this is without having a specific operating system config for each individual node, but just having one common operating system config with a custom, with a few changes here. That's all from my side. So handing over to Luca, unless there are any questions.
Nope. Cool. Thanks, Johannes. Then, Luca, it's your turn.
Thank you very much. Also, welcome from my side. I wanted to present the newly introduced Gardener API Go submodule to you that Marcel and I started working on in the last Gardener Hackathon in November 2025. It's actually an issue that has been open for a longer time, a request. And basically what we did is we introduced Gardener package APIs as their own Go module, so that projects can import only the API types if they don't require all the functionality of the Gardener repository and also pull the dependencies in. So what this will look like then is we had also before the package API, we had the APIs and we moved mostly the helpers and validation code out of the APIs and made them their own Go module so that only the types and a bit of necessary functionality is left, which also reduces the dependency, the amount of dependencies in the API types. So you can see that if you only import the API types, your project will be on a much lower footprint now. This also means that when updating to the new Gardner 1.137 version in a depending project, there will be then a separate require entry for the package APIs with the same version. For that, we also release a separate APIs tag in the Gardner repository. So this can then be easily consumed. And because we did a lot of refactoring by moving the packages, also here the time window or the configuration, the component configurations, we provided a gist here to help migrating most of the imports that we moved. So there will be a bit of change when updating, but this should be manageable as already some other components have updated and migrated their structure. So I guess this is it from my side, except there are further questions.
Quick question. Is the idea that by default you should be able to drop the Gardner dependency and only have the API dependency then?
If you don't need it, at least from now on, you're not required to pull the whole Gardner dependency in. So the APIs are consumable on their own. But depending on your repository or your project structure, it might be required to still pull in the full code when you need certain functionality. But for only the API types, you can now only consume the API types package.
So multiple extensions also use the hex script. Those are not included here, right? So if the extension relies on the scripts, then basically we still need to depend on Gardner.
Correct.
Okay.
Yeah, it's not only scripts. If you check extension, they use clients from package. They use the extension library, which is maybe also a good candidate for a submodule in the future. So yeah, I don't imagine right now extension to drop dependency on Gardner.
No. Yeah, but also good point from your side. So with this starting point made, we could also think of splitting up other modules to maybe better consume them in the future.
Yes, because right now I have more dependencies, not less. Okay.
All right. Then, thanks, Luca. This was also the final presentation for today, meaning we are done. So next week we have a special edition because we are doing the 1.35 Kubernetes review. And in 2 weeks, we continue then with the regular releases. Okay, then see you next week and have a good time. Bye-bye.
Bye.
See you.
Bye.
Bye.
Bye-bye.